Folks, we have a very special guest for you tonight. I'd like to introduce...
Let's begin. Alright now, wasn't that fun? Let's try something else.
What is magnetism?
Oh, I don't know.
I don't know either. Let's go look it up.
What are you guys doing?
Looking up magnetism.
I want to know who discovered it, when it was discovered, what things they did with it, and how and why, of course, and what life would be like without it.
Whoa, slow down, Elanger. Most of the work should be contributed to Michael Faraday.
The guy on the Cape, or was it lost?
Nah, Michael Faraday was born 1791. He's like the father of generators and motors. In 1831, he discovered electromagnetic induction.
Electron Mega Man Inception. What?
No, electromagnetic induction means basically to cause charge by using a magnet and wire. He created a transformer.
For real? I love Bumblebee.
I love Bumblebee from Transformers.
Oh, real Transformers. Once it came out before the hit blockbuster movie starring Shia LaBeouf and Megan Fox.
Megan Fox looks pretty good.
I know, right? But she quit and got replaced by a foreign model.
Dude,
Really?
focus.
I didn't know that.
Dude,
Right.
focus.
Okay, Jackson Silo, we're not here for that. Tell me more about these real Transformers.
Sure, the army made them to get wounded soldiers off the battlefield.
Cool, so who started the main youth thing of, magnetism? Yeah, that thing.
Well, I guess Faraday did it. He started the whole, if you run current through a wire, it creates an electromagnetic field.
That's correct.
Mr. Simba!
Our economy is in a crisis, and with you all, I've made a pact to help fix this incredible nation and get this country back on track. Thanks to Congress for passing the plan for which I took lots of flack. Now let me explain more, the American Recovery and Reinvestment Act. Now this package isn't perfect, and you can oppose my plan forever, but if we're opposites, let's be magnets and find a way to pull together.
Hey guys, so you guys are not interested in magnetism.
Ever since I saw 2012, the day after tomorrow.
This year for FRC, I use magnets in my robots and motors.
I know cool things like you put iron fillings next to a magnet, they create an electric field. Magnetic field.
Super cool, and I know some formulas.
Nerd.
Good, you all are very smart, and I'm glad to be your teacher. So Jakes, I assume that you know about magnetic fields and how they're created and such.
Yeah.
So Jakes, I assume that you know about magnetic fields and how they're created.
Yeah, like when you put a magnet on next to some iron fillings, they gather around the magnet and create a magnetic field. And the denser the particles, well not particles, the fillings are around the magnet, that's where the stronger the magnetic field is. And how magnetic fields can have B and H type magnetic fields. And I don't know, I just know about magnetic fields.
Very good. Let's start from the beginning. Last week we learned about electrostatics. What is the difference between electrostatics and current electricity?
I'm not even Electrostatics is the branch of science that deals with the properties of stationary and moving electric charges. Magnetism is a property of materials that respond to an atomic or subatomic level in materials.
Yes, it is. Well, if you know that, then why are magnets different than charges?
Well, magnets are devices that attract metals such as iron, copper, and tin, and produces a magnetic field. Charges are a basic property of matter carried by some particles.
You're just smart.
You know you smart too, Jakes.
Yeah.
Well, you know about magnetic fields, right, Jace? That also means you know about compasses.
Oh, compasses actually work by magnetized.
Yes, those things. Allow you to lie with poles.
Those align with the poles, right?
Yeah, the north and south poles. Excellent. Does anyone know if magnetic fields can affect atoms or subatomic particles?
Well, magnet fields are basically start at maybe definitely at the atomic level, and so I guess they kind of affect it, but not really, since it starts off kind of there. Because magnets are basically mini magnetic fields from the atoms all aligned together.
Now, if you have an electric charge that's moving, you create a magnetic field. But if these magnets are misaligned, so that here's a North Pole and a South Pole, and there's a North Pole and a South Pole, and they're all every which way, then the net effect is zero magnetism, and that's what most substances are. They have no magnetism.
But in some metals like iron, clumps of atoms line up and point their poles in the same direction. These clumps are called domains.
And suddenly you have an accumulation of all North Poles on one side, all South Poles on the other side, and you have a bar magnet.
Very good. I'm going to interrupt you because you guys forgot the reason why this was served.
Oh yeah, that's right. The only democracy in the world.
Yeah, that guy.
Definitely not support the
He did the reverse of what Faraday did.
Basically.
Wait, what Faraday was?
Stones at people who are he went from magnets to electricity.
So he's like the father of motors and generators, right?
Yeah.
Okay.
How do those work anyway?
Great question.
Turn that generator by any means you're making up. Electricity. A generator is a machine that contains a powerful magnet that creates a magnetic field. When wires are rotated rapidly through this field, then a current of electricity is produced. Now, if we only had a superhero who could stand here and turn the generator real fast, then we wouldn't need to burn so much fuel to make electricity.
So, what would happen if magnetism never existed?
Oh no. Oh, so they give him stuff to go.
Here's a short clip.
But they don't do anything else.
if somehow the laws of physics changed.
That's some creepy stuff, man.
I know, right? Okay. But you want to know the really cool part? I'll still
Like what?
like Transformers, robots, other things, bionic legs, some cool stuff, man. We've already done it. A lot of stuff in the last 10
What's that? It's a triox compound. Will help you breathe.
She lick me like a lollipop. What? I bleed it out. Yeah. She lick me like a lollipop. What? I bleed it out. She lick me like a lollipop. What? I bleed it out. She lick me like a lollipop. What? I bleed it out.
Yeah, here we go for the 100th time. Hand grenade pins at every line. Throw them up and let's jump and shine. Going out of my mind, filthy mouth, no excuse. Find a new place to hang this noose. String me up from atop these roofs. Not tight so I won't get loose. Truth is you can stop and stare. Let myself out and no one cares. Dug the trench out, lay down there with a shovel up out of reach somewhere. Yeah, someone pour it in. Make it a dirt dance floor again. Say your prayers and stop it out when they bring that chorus in. Bring that chorus in. Bring that chorus in.
I bleed it out, digging deeper just to throw it away. I bleed it out, digging deeper just to throw it away. I bleed it out, digging deeper just to throw it away. Just to throw it away. Just to throw it away.
I bleed it out, go, stop the show. Choppy words in a sloppy flow. Shotgun opera, lock and load. Cock it back and then watch it go. Mama help me, I've been cursed. Death is rolling in every verse. Candy paint on his brand new hearse. Can't contain him, he knows he works. This hurts, I won't lie. Doesn't matter how hard I try. Afterwards don't mean a thing, and I know that I won't be satisfied. So why try ignoring him? Make it a dirt dance floor again. Say your prayers and stop it out when they bring that chorus in. Bring that chorus in. Bring that chorus in.
I bleed it out, digging deeper just to throw it away. I bleed it out, digging deeper just to throw it away. I bleed it out, digging deeper just to throw it away. Just to throw it away. Just to throw it away. I bleed it out.
Greetings, teams. My guess is you're at a regional now. I was asked to do a quick message. On behalf of the whole FIRST community, to remind you that we have this really cool bowl program. Basically, it goes like this. If I said Girl Scout, a lot of people in this country would say cookies. Girl Scouts for years have used cookies as a way to A, raise money for all their activities, and B, get out into their communities and tell people who they are and what they do. We don't want to do cookies. The Girl Scouts have cookies. But for years, I've wondered why we don't have some great program that would get more kids involved with FIRST. Some want to build robots. Some maybe want to help develop community activities and involvement and run a business to raise money for FIRST. And we finally came up with the perfect alternative to cookies: light bulbs. But not just any light bulbs, really cool light bulbs. Ordinary light bulbs, as you know, take a lot of power. It's not good for the environment. They're glass and they can break. They can heat up and burn you. Or you could go to compact fluorescents, but they have mercury in them. And they're still glass and they're still fragile and they don't last as long, and we don't like the color of them. But here's a bulb that looks just like any other 60-watt bulb, except it's plastic, it won't break, and it's metal underneath. And it's not a fluorescent. This is LEDs. It doesn't get warm. It'll last for 10,000 hours. It's a really bright, warm light. We think they're great. The only problem is, these days, like all new technologies, they're very expensive to make. And if you tried to buy these, if you could get them anywhere, which you can't, but one's not even as good as these, costs $30 or $40. We got a lot of help from our friends at Google. They wanted to help us give our teams a way to get out in the community and raise money, so they said, we'll give you millions of dollars to help put these bulbs in the hands of the students at a reasonable price, and then they, in turn, can go around their community to businesses and to people that need nice, energy-efficient, environmentally friendly light bulbs. We started the program late, I must admit, right in the middle of build season, and you were all busy. But some of the teams have already figured out how attractive they are, and they've gotten really good at selling them, and they've sold case after case after case of them. I'm hoping by this message, those teams that haven't learned about the programs will take advantage of it. Get to the first people, tell them you want to start getting involved, and over the next few years, I hope we develop a tradition at first that's as good for us as cookies are for the Girl Scouts, and that we help populate the world with clean, efficient sources of light, and we hope that each year we have new and more interesting products to give you. But I just wanted to let everybody know we worked hard to help you help yourselves at first, and we think these bulbs are a bright idea. They're a good start, and the light bulb, that kind of the image and icon of innovation, is now out there for you to use to help grow first, raise some money, and raise some awareness. Give it a try. Thanks.
So in the real world, are we the only ones who use magnets?
Wouldn't have been pissed
no. Yeah. I don't know.
Yeah. They're not pissed at us.
I mean, they're like animals that use
They declared March. They never.
Yeah, that's it. They're magnets. And like
the
pigeons, dolphins, some forms of bacteria.
Yeah, bacteria can do it too.
But as wartime messengers, pigeons headed home without sunlight and bridges to guide them. There had to be another technique the birds were using to find their way. The answer came on a cloudy day in 1974 when Cornell University researchers attached magnets to pigeons' heads. Birds that normally flew directly home became hopelessly disoriented. Findings that pigeons can use magnetism to navigate prompted new studies in animal migration.
One of the most intriguing aspects of all of this work is simply that you have a large number of very simple animals that evidently have evolved the ability to perceive something that we ourselves cannot see.
It is late autumn, and off the coast of Florida, spiny lobsters are on the move. Their only chance at survival is to reach the warmer, calmer depths before winter.
They're able to hold their courses despite the fact that they often migrate at night. They often migrate when a tremendous amount of sediment is suspended in the water so that visibility is rather poor. And they're able to migrate under conditions in which waves and water currents are impinging upon them from different directions.
To find out if lobsters have a magnetic sense, Ken Lohman set up a tank where he can control the magnetic field. Once in the tank, the lobster on a leash orients itself based on the existing field in the tank.
Going, so we just have to wait for the lobster now.
This is a north-seeking lobster.
All right, we'll change the field in 5 seconds.
Nothing diverts the creature from its course until the direction of the magnetic field is reversed.
Our results from the laboratory experiments demonstrate that lobsters have the ability to orient by sensing the Earth's magnetic field. This suggests that they may be able to guide their migration by detecting the Earth's magnetic field.
Out of Ken Lohman's clutches, the lobsters do what they ought to do, a migratory dance along magnetic lines of force. The question is, how small can you go and still find biomagnetism? Richard Frankel collects bacteria from saltwater marshes on the California coast to study their magnetic properties. These bacteria have a problem. They seek food and security in the muck under the pools of water, but they don't have eyes to guide them, and they are so tiny they're unaffected by gravity. The bacteria may be simple single-celled creatures, but they navigate the same way Columbus did.
Looking at the monitor here, we can see bacteria swimming out of the sediment particles and accumulating at the edge of the drop, which is closest to the yellow end of this bar magnet. And now after they've accumulated for a while, I can show you that if I turn the bar magnet around, the bacteria swim away from the drop.
Unlike the pigeons and lobsters, we can actually see the bacteria's internal direction finder. This is a picture from an electron microscope, the organism magnified 100,000 times. The bacterium is a living bar magnet.
Well, what the bacteria did, or what they do, in fact, they're doing it right now out here, is they make these single domain sized particles of magnetite and they line them up in a chain. And this forms a permanent compass needle that is just large enough so that the bacterium is oriented in the Earth's magnetic field as it swims.
But are the bacteria actually heading north? Not really. They're swimming down to where the food is. It works just like the floating needle experiment.
If this is the north-seeking end of my internal compass needle, if my flagellum is back here, if I just start swimming straight ahead, then the Earth's field will align me in a particular direction and I'll swim down to the sediments. When you look at these bacteria, you see this chain of particles looking very much like a backbone running through the cell. And in fact, there's an interesting correspondence between the fact that bacteria can mineralize, can produce an internal mineral.
What would happen if there was no magnetism? Why is Earth called a giant magnet? How can travelers use lodestones? What are northern lights? What did Faraday discover? What is tokamak?
Integrating different areas of science can help you come up with new ways to do things, and the possibilities are endless.